Welcome to my Physics Lab 5 Chicken Jockey. For this experiment, I will be observing the movement of a falling chicken jockey. Then I will create a computational model of a mass falling from a certain height which represents this chicken jockey. And the purpose of this experiment is to explore the principles of physics, including Newton's second law, gravitational force, gravitational potential energy, and kinetic energy. Here's a preview of the computational model results, with the left showing the change in both the kinetic energy and gravitational energy over time, and with the right showing the change in the y position over time as the chicken jockey falls. In this scenario, the system is the object that you're observing, which including both the chicken jockey and the Earth, which leave the surroundings to be just the air, but we're choosing to ignore this for this model or this experiment. One important principle is Newton's second law, which is used to derive the velocity update formula. This is the position update formula, and it is also a crucial physics principle for this lab. Here's the force of gravity near Earth, which is negative mg in the y-hat direction. The important energies used for this lab are the kinetic energy, seen on the left, and the gravitational potential energy, which is seen on the right. Here's the video that I'll be analyzing throughout the
Chicken jockey!
Now I'll be going over the computational model that I created. My initial conditions include a few assumptions, which include the mass of the chicken jockey being around 8 kilograms and the position of the chicken jockey being 6 meters high. And then I've also included here the initial kinetic energy, the initial gravitational potential energy, and the initial total energy. Now I will be going through my calculation loop, which starts with, again, defining initial energies, and then I found the gravitational force, and then the net force, which is simply equal to the gravitational force, as this is the only force being applied in this situation. And then I applied the momentum principle, which is the velocity update formula, and using this velocity I applied the position update formula to move the ball as it falls, just because it's a ball and the model is actually referring to the chicken jockey. And then I've also calculated the energy changes, which includes the kinetic energy, the gravitational potential energy, and the total energy. Here is one of the outputs of my code. The blue ball falling refers to the chicken jockey, and the yellow ball in the middle refers to the ground or the ring that the chicken jockey lands on. Here's my coding output, which shows delta K, which is the change in kinetic energy, increasing as the chicken jockey falls, and then it also has the change in gravitational potential energy becoming more negative the more it falls. And then you can see in the middle that the change in total energy is 0 throughout. Then on the right, you can see the Y position as the chicken jockey falls. For computational model, the results were as expected because it had the energy principle being satisfied throughout. However, the only negative is that it didn't account for when the chicken jockey hit the ground, which you can see the gravitational potential energy at the final should be 0. However, it did not have that being 0 in the change in gravitational potential energy in the graph, so that's the only mistake there. So that mistake in the code is one error that isn't quite fixable in a reasonable coding session. And then I did take many assumptions for this experiment to work, which could cause some errors. And then also, I'm not perfect. I could have made a few coding errors. However, I did check it a lot, so it should be right. Now, this model does act according to the laws of physics because the energy principle is satisfied. Since both the Earth and the chicken jockey are in the system, work equals 0, and there's no heat transfer, meaning delta K plus delta UG should equal 0, and that was satisfied. Now, if only the chicken jockey was chosen to be in the system, which makes the Earth and the surroundings, the energy principle formula would look slightly different, which you can see the two different systems on the left and right. However, when you work them out and move everything around, it ends up being the exact same. Thank you for listening to my Chicken Jockey Lab.